Kia ora whānau. Today we're going to talk about testing RCDs. So before we start, let's have a little talk about the RCDs themselves, a little bit of background on what that device is. So RCD stands for Residual Current Device, and this is a safety device that we find both in switchboards and in portable form, either on a lead or as a self-contained device that we use to provide personal protection against electric shock. Personal protection meaning protection for people against electric shock under fault conditions. And as you may already be aware, I'll very quickly run through how an RCD actually works. It's measuring the current or the difference in the current between what's coming in on the phase conductor of my circuit and what's returning on the neutral current. The principle behind the RCD is that if we have current going down the phase into my circuit and a lesser value of current returning on the neutral for that circuit, we must have some current going elsewhere. Some of our return current is going elsewhere. And the assumption, in the case of the RCD, is that return current is going via somewhere we don't want it to go, either along our earth wire due to some sort of fault in a plug or a device, appliance, or part of the circuit where we have a fault and we've got current flowing to earth. Or in the worst case scenario, we have some sort of fault and current is flowing through me, through my body to earth. Either of those cases are bad and they are dangerous to people. Clearly, if I'm getting an electric shock at the time, that is dangerous to me. So in that case, our RCD operates to disconnect the supply. It switches off, it kills the supply and removes that fault then from the circuit. And again, it does that by measuring the balance between those two currents. If some current is flowing back through the earth path, then the RCD will detect that and trip. So we're going to look at testing our RCDs. Now, to do that, we're going to have to start with our legislation. What tests do we need to do? Well, as I said, we can either have a portable RCD, which is either a standalone device which I plug in, or an RCD as part of an extension lead, and we'll often see those on building sites and that sort of thing. Or we may have RCDs in a switchboard, and here in New Zealand it's required by the legislation that we must have RCDs protecting all socket outlets in domestic installation, so in houses. So you'll come across these all the time. Every single house built after that rule was brought in about 12 or 15 years ago, I guess, must have RCDs built into the switchboard. And we should, obviously, if we're installing them, we should test those. So let's have a look. We've got three different places that we need to look for this information, unfortunately. But lucky for you, I'm here to show you where to go. So we'll start here with, we've got ASNZS 3000. So this is our legislation as it relates to installations or buildings. And it says here in section 8.3.10.2, tests shall be performed on each final subcircuit protected by an RCD to verify that the RCD operates to disconnect the designated circuit. And it talks there about the tests we must do. In this case, all it says is that the RCD must disconnect the supply. And we can do that by pushing the RCD test button, which I'll show you shortly. And that's all it says. It doesn't say that I have to do anything else. It says I must push the test button and ensure that the RCD disconnects the supply. So that's a fairly simple test. This is in section 8 of ASNZS 3000, which is verification. It's our testing section. So this details all of the mandatory tests that we must do once we have completed work on an installation or part of an installation, and we're putting it into service. We're putting power onto it for the first time. So if we install a new RCD or work on a circuit that is connected to an RCD, we must push the test button in order to verify that the RCD will operate. Okay, so then now we're going to look at ASNZS 3760, which is for appliance testing, what we would commonly call test and tag. And if an appliance, either some sort of multi-box, you might see lifeguards on building sites, or a standalone RCD or RCD as part of an extension lead, all of those fall under the definition of an appliance and require testing and tagging at various intervals depending on the situation, and that's all detailed in ASNZS 3760. We won't go into that today, but we must also test the RCD on that one. And this one says that it has maximum tripping times here, so rather than just pushing the button, we must do a test to ensure that the RCD operates at a certain current value and with a maximum tripping time. And in this case, type 1 RCD, 10 milliamp RCD, we tested at 10 milliamps. Type 2 RCD, we test at 30 milliamps. And the maximum tripping times are 40 for the type 1 and 300 milliseconds. So that's 0.04 seconds or 0.3 seconds for the type 2. Just a quick mention then of what those ratings mean. Every single RCD is constructed with a specific fault current in mind. How much leakage current down the earth path, as we said, is required to trip that RCD. We don't want it to be too low because that will just trip all of the time. And part of most electric circuits will have a small amount of leakage in them, so we don't want it to be too low. For our domestic situations or our portable RCDs, we're generally going to find 30 milliamps is our number. 30 milliamps is the current that will trip that RCD. For hospitals, kindergartens and primary schools, we will see 10 milliamp RCDs. But today we're just going to look at 30 milliamp RCDs. The process for testing a 10 milliamp RCD is the same. Obviously, the testing values will be different, but those are again detailed in our legislation. If you're testing a 10 milliamp RCD, that's where you go to find it. So the third piece of legislation that we want to look at is going to be the electricity safety regulations. And we find here in Regulation 24, electrically unsafe RCDs, this details what an electrically unsafe RCD is defined as. So that means that if it doesn't comply with this, then it is unsafe. And we see here an RCD used to protect against electric shock, and that is installed as part of an installation or as a portable RCD. So that's all the things we talked about. An RCD used to protect people against shock, and it's installed in an installation such as in a switchboard in a domestic building, or a portable RCD, a standalone RCD, or as part of a lead. It's deemed to be electrically unsafe if it has a rated current exceeding 30 milliamps. So all our RCDs must be 30 milliamps or less. Generally, we'll find they will be, the rated current will be 30 milliamps. And it does not interrupt the current in all live conductors within 300 milliseconds when passing its rated current, or 40 milliseconds when passing 5 times its rated current, or if it interrupts the current in the live conductors when passing a leakage current at or below half its rated residual current. So this is where we're going to get the tests we're doing today. ASNZS 3760, the test, we just have to test at the rated current for a specific time. And with ASNZS 3000, it just tells us to use the test button. But this here tells us what an electrically unsafe RCD is, which then obviously we can use to infer what a electrically safe RCD is, one that passes these tests. This regulation does not tell us when we're supposed to be doing these tests. We would then go to ASNZS 3000 or 3760, but those standards don't tell us anything about these tests. So what we're going to do is we're going to assume that as the installer of the RCD, that we should be the ones who are testing the RCD to meet these standards here, because this is the highest standard that we find in those three pieces of legislation. It's a little bit confusing there. It's a little bit unclear as to who's supposed to do what and when these happen, but it's generally assumed in industry that as the installer, we would do this test here to ensure that RCD is compliant. And of course, as with any of our testing, it doesn't hurt to test a little bit higher than maybe what is specifically required. We can always be a little bit safer, right? And it doesn't take too long to do this, so it's no problem. So these are the tests that we're going to go through today. We're going to test at the rated current and check that RCD trips within 300 milliseconds. We're going to check at 5 times the rated current and check that it operates within 40 milliseconds. And we're going to check at half the rated current and make sure that it doesn't trip at all. This is to ensure that our RCD is not too sensitive and it's not going to nuisance trip when we don't want it to. So let's have a look at our RCD. Then we can see here that we have a switchboard setup. I have a switchboard set up here. As per my previous videos, important to note, this is not in any condition that you would see in a normal building installation. This has been constructed specifically for the purposes of doing this test to enable you to see what's going on. We have a socket inside the switchboard here that's just connected to this RCD. See that RCD there. And I have my RCD test meter, which I'll show you more shortly. So let's just, the first test, we can just push the test button as it said in ASNZS 3000, and we have our test button here. If I hit that button, you can see that the RCD operated. Now let's have a look at our RCD tester. This is a multifunction tester, so it does many things, but we're going to focus on the RCD trip time setting today. Your tester may look different, but it should carry out the same functions. So there's a few things that we need to check before we start here. First, we're going to select the correct RCD rating. If I was using a 10 milliamp RCD, I would select 10. This one here that we're using today is a 30 milliamp RCD. So I make sure by pushing F1 here that I select the correct rating. You'll see that obviously this meter is able to do various ratings, but we come back to 30 milliamps, so that's the correct rating there. Down here you see ×1, so that's going to tell us what test I'm running. So as I said, we need to test it at the rated current. That would be ×1 the rated current, at 5 times the rated current, and at half the rated current. So we're going to use F2 to switch those, but for now we'll test it at the rated current. So the first test we're going to do, will the RCD trip in the required time at the rated current, in this case being 30 milliamps. The last thing we'll just look at here is we've got a 0 degrees sign down here, and this is something that's done often, and we will do it today. It's not referenced in any of the legislation that we've looked at, but this is testing either on the positive or negative half cycle of my sine wave. So if I push F4 here, you'll see that changes to 180. So when it says 0, we're testing the positive half cycle, and 180 we're testing the negative half cycle. That we're testing there to ensure that it will detect a fault current either in one direction or the other, because on our AC supply we have current flowing, alternating current flowing in both directions. Not required by the standards again, but we will do that today because we can, and it's good to ensure we test everything that we can. So I'll start with 0 degrees at 1 times the rated current. I've selected obviously the RCD time selection, so we're going to trip the RCD and see how long it takes. When I hit test, this meter is going to simulate that fault current that we talked about before, fault current flowing on the earth path. The RCD should clearly pick that up and recognize that as a fault, and when it does, it will trip, and we're going to check that it trips within the required time. So I just push the test button, and we see that our RCD tripped there, and the time that shows up is 25 milliseconds. Now, as we saw before, our requirement in the electricity safety regulations for the rated current is 300 milliseconds. So we tripped it in 25, so that is much better than is required. I've reset the RCD. I'm going to switch this to 180 degrees to test the negative half cycle, and I push test again, and we see 34.3 milliseconds. So again, that is much lower than the 300 milliseconds that is required. Once again, I reset the RCD. I obviously need to do this between every test, because the RCD is not going to operate if it's already switched off. And I'm going to change my rating from ×1 to ×5, because that's our next test. So we're now testing our 30 milliamp RCD at 5 times the rated current, and we'll go back to 0 degrees or positive half cycle. And according to our electricity safety regulations, at 5 times the rated current here, must trip within 40 milliseconds. Obviously, our device will trip faster the higher the current is. And we saw that with the rated current, 30 milliamps, we were still well below even the 40 milliseconds required for the 5 times test. So we should be well under 40 now that we've switched that current up. Let's have a look. So again, 30 milliamp RCD, 5 times the rated current, 0 degrees. Hit the test button, and we see that it's tripped within 7 milliseconds. Just like a circuit breaker, the higher the fault current is, the faster our device is likely to trip. Reset. Go to 180 degrees. Test again. 12.5 milliseconds. That's well under our 40 milliseconds that is required. So those are our tests that are required to ensure that the RCD trips safely at those 2 different fault currents. And the third and final test that we need to do is to test that RCD at half the rated current. So I push F2 until I get half. We're still on a 30 milliamp RCD. We'll switch that back to 0. And what we should see in this one is that the RCD does not trip. The RCD tester is going to pass a 15 milliamp fault current, and the RCD should not trip. And we can see there it says greater than, the greater than symbol, 2000 milliseconds, which is 2 seconds. So what the RCD tester is telling us is it's passed that fault current for 2 seconds and nothing happened. You can see our RCD did not trip. So that is a successful test. We're now going to change to 180 degrees. Everything else remains the same. Test again. And again, we did not get a trip. RCD tester is telling us greater than 2000 milliseconds. I've tried to trip that for 2 seconds and nothing happened. So how I would record that result is no trip, and that is the correct result. So those are essentially the 6 tests that are required, or 6 plus 1, which is the push button test on the RCD, required to ensure that our RCD is safe according to the electricity safety regulations. Again, there's a little bit of confusion between those 3 pieces of legislation as to when those tests are supposed to happen. But what we can say is that if we do all of those tests ourselves, then we're certainly not going to go wrong. I've obviously demonstrated that using a RCD in a switchboard, such as you would find in most electrical installations, certainly within domestic installations, and you may find them elsewhere as well. People do install RCDs where they're not necessarily required by law, just to make things a little bit safer. But the testing process that you would follow for a portable RCD is identical to that. There is no difference. You would perform the same tests in exactly the same way with the same meter. You're just plugging into the RCD, the portable RCD, as opposed to directly into a socket out there to test the RCD in the switchboard. Hopefully that helps you. Join us for the next video. As ever, if you have any questions and you want to know more, hit me up in the comments. I'm happy to help out. Thanks for your time.